All right, you guys, today we're going to look at an introduction to trigonometric graphs and specifically graphing the sine and cosine functions. So let's go ahead and try it. So here is an axis that we use when we're graphing trig functions, and it comes from the unit circle. So on our unit circle, whenever we measure sine and cosine, we measure sine and cosine of certain angles. And so basically what we've done is we've taken the unit circle, which is laid out starting at 0 radians or 0 degrees, and then the first angle up from there is pi over 6 radians. The next angle up is pi over 4 radians, and so on and so forth. And so what we've done is we've laid out all of those angles on our x-axis so that we can calculate sine and cosine at those angles. All right, so we're going to start with our sine graph. And so the coordinates of your sine graph are going to be x comma y, where your x value is the angle measurement. And then the y value is going to be sine of that angle. Right? And a place you can look for these if you don't know necessarily off the top of your head, like sine of 2 pi over 3 or sine of 3 pi over 4, is you could use from here, these would be the y coordinates of your terminal points at each of those angles. And so that's how we're going to do our 5 major points of the sine graph and how you could graph every piece in between as well. So we're going to go ahead and I'm going to go ahead and stick a 1 up here and a -1 down here, and you'll see why in one moment. So if we're graphing at our 5 major places, usually on your unit circle, it's very easy to find your sine and cosine values at each of your quadrants. Or excuse me, at each of the axes. So at 0 radians, pi over 2 radians, pi, 3 pi over 2, and then again at 2 pi if you go all the way around your circle. And so we are going to be graphing our 5 major points at these x coordinates, and then zeros over here. So let's go ahead and do sine of 0 first. So sine of 0, if you look on your unit circle, sine of 0 is in fact 0. Different color. So we would graph a point right here. This would be the point 0 and then sine of 0, which is 0. Okay. Then our next point, we would be graphing at pi over 2. So sine of pi over 2 is 1. So if I was looking at what that point, where that point comes from, it'd be at the angle measurement, pi over 2, sine of pi over 2, and so on and so forth. So that's how all of these angle measurements play into graphing the sine and cosine graph. Okay. All right, so let's go ahead and clean up a little bit. Next, we're going to be graphing at sine of pi. Sine of pi is 0. And then we go 3 pi over 2. Sine of 3 pi over 2 is -1. And then sine of 2 pi is here. And so you get your sine wave. Oops. More or less. And this would be one wavelength of your sine graph. It does technically continue and repeat itself. It's very cyclical, and it starts to do what we call oscillate. So it's going to make this pattern over and over again for all time. Awesome. All right, in this next section, we're going to do our cosine graph. And so we use the same 5 major angles. So 0, pi over 2, pi, 3 pi over 2, and then back around to 2 pi. And when we graph our cosine coordinates, what you're graphing when you're graphing the points on that line is you're graphing the angle measurement, and then you're graphing the, instead of sine, we did sine of theta. For cosine, obviously, you'll use cosine of theta, would be your y value. Cosine would, if you're not familiar necessarily with cosine of each of these angles, you can also be looking on your unit circle at the x coordinates of your terminal points. Okay, so if I do, there's a 1 and a -1 here, and I'm going to be graphing, like I said before, at my same 5 major angle measurements, so 0, pi over 2 pi, 3 pi over 2, and 2 pi. Cosine of 0 radians is 1, if you look on your unit circle. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is back up at 1. So again, we get a nice wave. And that's one wavelength, and then it will begin to repeat itself as well. Okay. One major difference between your sine and cosine graphs is that cosine doesn't start, the most basic cosine graph doesn't start at the origin. So if you're trying to tell the difference between the two, because they do have wave-like structures for both of them, is that your cosine graph looks more like a shrug, or it starts high is another way I like to phrase it, whereas your sine graph starts at the origin, or goes to the origin. And these are for your most basic sine and cosine functions, okay? All right, so now let's go ahead and look at some properties of our sine and cosine functions. So the period of a sine and cosine function is basically another way to talk about the period of a trig function is to talk about your one wavelength. And so the period of one wavelength of sine before it starts to repeat itself, or one wavelength of cosine, is 2 pi. That means that one wavelength of sine fits between 0 and 2 pi on the basic sine function, and one wavelength of cosine does the same thing, fits between 0 and 2 pi. Before that and after that, it'll just start to repeat itself over and over again. So in your own words, write down what the period of a sine or a cosine function is. I'll leave that up to you as what you will write down your own words. But one thing I want to make sure to emphasize is that the domain of a sine or cosine function and how it's different from the period. So while one wavelength might fit between 0 and 2 pi, the domain is really what is your function doing, or how many of the x values does it hit? What x values does it cover? And since both the sine and cosine graph continue forever to the left and forever to the right, even though one wavelength fits between 0 and 2 pi, both sine and cosine have a domain of all real numbers because they repeat themselves, but then they do it for all time. So no matter what you do to your sine or cosine wave, this will always be true. So there we go. So that's everything having to do with horizontal characteristics of sine and cosine, right? How long it takes for one wavelength to occur, and then how long does your graph extend? We're also going to be looking at amplitude and range, which means the height, or basically how to deal with your properties vertically. So for sine and cosine, they both have an amplitude of 1. And another way that you can talk about amplitude is the distance from your midline. And I'll talk about what a midline is. So with these graphs, with any sine or cosine wave graph, the midline, regardless of where it is, because sometimes these graphs could move up or down, the midline is what cuts your trig function directly in half. And then the distance from the midline is just how far up or how far down it goes. So if I was looking at these two examples, here my midline is the x-axis. So what is this distance down, or what is this distance up from that midline? Well, in either one of these scenarios, the distance is 1, and therefore we say that our sine and cosine graphs have an amplitude of 1, the distance from the midline. Okay, so if you want to write down in your own words what that means and how you can remember that, that's awesome. But it's important to know that while your amplitude is just how far from the middle your graph is, the range is total from the very top of your graph to the very bottom of your graph. What is the range of your function? And both of our basic sine and cosine functions have a range from -1 to +1. That can change depending on whether you change your function at all, but the basic sine and cosine functions have a range from -1 to 1.